Hello everyone! Today we'll be presenting my project on packet sniffing using Python, where we'll explore how network traffic monitoring helps in cybersecurity. A packet sniffer is a tool used to capture and analyze network traffic in real time. It helps in monitoring the data being transmitted across a network. Why is packet sniffing important? It helps in troubleshooting network issues, detecting suspicious activities, preventing cybersecurity threats. Some popular packet sniffing tools include Wireshark, TCP dump, and Scapy. For this project, I used Python and Scapy to build a lightweight and customizable network sniffer. With the rise of cyber threats, hackers exploit network vulnerabilities to steal sensitive information. Organizations need real-time network monitoring to detect and prevent such attacks. To solve this, I created a Python-based packet sniffer that captures network traffic and analyzes potential security risks. The main objectives of this project are monitor network traffic and capture real-time packets, analyze data packets to extract useful information like IP addresses, protocols, and ports, filter specific traffic focusing on HTTP, HTTPS, and DNS packets, log network activity for later security analysis. For this project, I used a computer with Python for programming a Scapy library for packet capture, a network interface with npcap, Windows, or TCP dump, Linux, for network sniffing a CSV file to store captured data, a tkinter library to create a basic GUI for real-time monitoring. Here's how the packet sniffer works. Step 1. Capture packets using Scapy. Step 2. Extract important details like source and destination IP, protocol, and port. Step 3. Filter out unwanted network noise like multicast packets. Step 4. Detect suspicious IPs and raise alerts. Step 5. Log captured data for further analysis. This allows us to monitor real-time network activity and enhance security, domain names, and CSV to log the data. Next, we define ignore IPs to filter unnecessary traffic and suspicious IPs to detect malicious connections. The core function, packet callback, captures packets, extracts source and destination IPs, checks for suspicious traffic, and logs everything in a CSV file. Finally, the sniff function continuously captures and processes network packets in real time. We can see packets being captured, showing protocol type, source, and destination IPs. For example, we see TCP packets to Google servers, DNS queries to resolve domain names, and local network communication. If any packet matches a suspicious IP, the program immediately raises an alert, helping in real-time network monitoring and security analysis. Now let's look at the network traffic.csv file, where all captured packets are logged. Each row contains timestamp, when the packet was captured, source and destination IPs, who is communicating protocol, TCP, UDP, or DNS port number, which service is being used. This file helps in analyzing network behavior and identifying potential threats. Some challenges I faced were WinPCAP was outdated. Solution: installed npcap permission issues in Windows. Solution: ran the script as administrator excessive packet capture. Solution: implemented packet filtering to capture only HTTP, HTTPS, and DNS traffic. Going forward, I plan to add a GUI dashboard for better visualization, integrate with VirusTotal API to check if IPs are malicious, store logs in a database, MongoDB/SQLite, for structured analysis, improve packet filtering to capture only security-relevant traffic. In summary, this project successfully built a Python-based packet sniffer that can capture, analyze, and log network traffic in real time. It can be used for network monitoring, security analysis, and cybersecurity research.